All righty, looks like the attendees have stopped coming in, and I just want to say good afternoon, good evening, good morning, depending on where you are in the world. Thanks everyone for joining this Midwest University presentation. My name is Brian Mackey. I'm here to give you a presentation on everyday uses of adaptive components. Some of you may have seen similar presentations to this. I give a lot of adaptive component presentations. I do believe in them. I use them quite often. However, they are very nuanced, so I always like to try to cover some of that stuff with people. I will go ahead and say we do have the chat panel open, so feel free to chat with everybody as you're going through. Say good morning, good afternoon, good evening, depending on where you are. Also, we have the question and answers pod open, so if you do have questions, please pop it in there for myself and Justin, who's in the background, trying to go over questions and stuff. It's really nice to be able to do it through the question and answer pod. It's a little bit easier to keep track of. But again, feel free to heckle everybody on the chat, do anything you feel like doing there. I also encourage questions along the way. I'm not a person who likes to answer questions at the end of a broadcast because I like to answer them on the spot as we go through. So if I see that question pop up, or if Justin sees one pop up that's relative to what we're doing, he might hop in here and say, hey, got a question for you. But with that, we're going to head and jump into this. And for those of you who've never seen me present before, I'm usually mostly an all hands-on Revit person. I do have a couple PowerPoint slides, but not that much. So I do also want to give a shameless plug here once I activate this again. So I do want to give a shameless plug. I do a monthly webcast called Revit Radio. It's where you guys can ask any Revit question. And I do see actually a few of my Revit Radio regulars on here. I do let you ask any question and I answer it live on the spot. I will say that unless there's an MEP person in attendance, I don't do well with MEP questions. But if you're structure architecture, we could usually jump in on those. So there is my shameless plug. So just by show of hands, I didn't do any polls or anything, but just by show of hands in the attendee in your little attendee list, who is architecture? Okay, so we got a few people on the architectural side of things. Cool. Then I'm going to ask who's in structure. So it looks like mostly architectural people here on the little raising the hands. Cool. And then the other question is, who has used adaptive components frequently? So we've only got a couple people who said they've actually used adaptive components frequently. So that's always fun to hear, sad to hear, but good to know. It's one of those things that I use adaptive components regularly. I did give a presentation at AU, I think it was in 2019, with one of my clients. That was actually back here in the slide. That was this particular project here. So this is my Revit adaptive component family here. This is a little bit crazier thing, but this was just a stone panel project. It's an AU presentation. You can look it up. But it was one where every single one of those stone panels are a Revit adaptive component. They're all modeled accurately with the gaps and everything, including the little window pane things inside of here. I believe heavily in adaptive components, but not everybody's going to be using those crazy curved walls like I just shown. So that's why I always call these like my everyday uses of. Probably the one that most of my clients use quite often is my little roof cricket sample here. Sure, sometimes it's great to go in and model that with its own individual roof. But if we do that and the roof starts to adjust, we'll need to jump in and start adjusting those individual roofs. So when I'm in preliminary design, schematic design, heck, usually through DD, I have a little adaptive component family I do. It works great. And then when I get into CDs, when I need to see the insulation or the framing or whatever else below it, a lot of times I'll come back and replace that with a real roof. So that's just kind of an example I have. Some of the other tools, oh, I lost, nope, there it is. So I've got like, hey, I've got some sort of crazy steel connections here. All these things are doing different weird things. I've used steel connection examples for that. Down here, this is actually a live, this is one for one of my clients. This is a much simplified version of it, but this is one that I've presented on, I believe, at Builts. But this is one where you can use adaptive components and reactor points too. So like this reactor point here moves, all of these different panels will start changing their angle based on a formula put in. So these are things that you don't necessarily have to be doing crazy panels or, curtain panel systems, etc. You can start doing different things. And then for my few structural engineers out there, these are two structural families that I use quite often. And I will show these in this presentation on just getting in and adjusting these types of scenarios. I think with that, we're just going to jump in. So as we start getting into Revit and we start looking at this, there are a few different types of templates when you get into there. So if I was to go to new family and I go down here to the templates, once I start getting into those templates, what you're going to see in English Imperial, and we've got a couple different templates that you could technically use. You could use curtain panel pattern based. A curtain panel pattern based family is an adaptive component. The difference between this and using the generic model adaptive is you cannot add points, more adaptive points to this. You also cannot then use shape handle points either. Most people don't even know what those are. We'll talk about those in a second, but that's the difference between curtain panel pattern based and then the generic model adaptive. So really there's not that much difference between the two except for those there. So honest truth, even if I'm doing a generic model adaptive or a curtain panel pattern based, I could use those as manual placement objects, or I can put a generic model adaptive into a curtain panel setup by divided surfaces and masses. So we're just going to start with this out of the box generic model adaptive. And when I get in here and start looking, you'll see that this environment does look completely different than the Revit family editor. The biggest thing to this is it's going to look a lot like the massing. But when we start coming in here where this is different than the massing environment, is if we do go put a point down, so we come up here and grab our reference point and place it, it's still going to look just like a point, but it gives us the capability to select that point and then come up here and do what's called make adaptive. You can do it up here in the make adaptive button, or you can also change that point in the properties from a reference point to a placement point or a shape handle point. And we'll talk about that in a second. So what these adaptive component families are is as you place points, those points then become tools or objects that you can click on back in the project. So I'm gonna switch back to my project environment here, and I'm just gonna go place one of these families down here. So if I were to come down and grab any sort of adaptive component family, and pretty much this particular project of mine, they're all adaptive, I can start placing this. And what's fun about an adaptive component family is I'm going to come down here and I'm just going to grab this one called rectangle 2 point, right? So I'm going to grab this. Is if I take this rectangle 2 point, the adaptive component will let me host the adaptive point on something in the model, and then come down over here and host it on something else in the model. So I can go grab this wall and then grab the end of this beam. This is a horrible example, but you'll get the point here. And what's great about the generic model adaptive, I grabbed it through a linked file, is if that object moves, the adaptive component will move with it. And this is why they're calling it an adaptive component, is those points that you place in the family get hosted in the project environment onto an element. What's also cool about that is if I come down here, I'm going to go into wireframe real quick. If I can find where that point is and I select that point in the project environment, I can now say pick new host. So if I didn't want hosted to this beam, but I want it hosted to the end of this beam, I can pick a new host just like any pretty much other family that we can do in Revit with the pick new host. But the other thing that you can do is if I can come in here and grab that same adaptive point, rotate around, I can't see it. If I grab that point as well, then not only can you do that, but you'll also see that we get properties within the project environment. You will get these same properties in the family environment on the points that are hosted within the family environment. But in the project environment, you'll start getting these different values. Now, if I host it to an edge, so like a line on an edge versus a surface, I would get different properties. So this one I hosted to an edge, so I get measurement types. If I hosted this on a surface, I would get U and V values, so I could move and rotate that up on the surface. But what's cool about this is I can come up here and say, you know what, I needed this to be 6 inches from the end. So I can change it from a normalized curve parameter to a segment length. If I'm like, ooh, I wanted that segment length to be 1 foot away. Now that point is hosted 1 foot away from whatever I hosted it onto, right? So you can change it from segment length to normalized curve parameter, which is then basically just a percentage between 0 and 1 of where you want it to be. So if you wanted it to be at the midpoint always, you can change it to be normalized curve parameter, change that to be 0.5, and now that point is hosted there. So where this becomes really, really, really nice, I'm going to go back in headline mode here. Where this becomes really, really nice is if I come over here to this little roof I have, we can kind of do that with like this little roof cricket family. So this roof cricket family, I want this to be 8 feet from the end or 10 feet from the end. So when I place this roof cricket, I did place it on this valley inside of here. And if I were to come back and be like, no, that needed to be 10 feet from the end, as I change that to be 10 feet, you can see this value adjusts, right? The other thing, like I said before, with the adaptive component families, is let's say somebody edited the footprint and they're like, ooh, I wanted the slope on this side maybe to be half of an inch, not 1 to 12. And as that ridge line, or excuse me, that valley line moves, all of a sudden my roof cricket is moving with that. Now, one downside to adaptive component families, I've been complaining about this since they came out in Revit 2009, is the fact that they will not give you a warning when they go bye-bye. So if they just decide they can't be hosted to something or something weird happens in that scenario, you don't get a warning that the element's being deleted. It just gets deleted and disappears. So I always like to point that out when you get into things and you start setting these things up, is the fact that, hey, it's going to come in here and possibly just disappear on you with no rhyme or reason on it. Now, the other thing about adaptive component families is as you go to use them, kind of need to know what's going on. So you will see with all of my adaptive component families, I come through here and I have like 2 point next to a 4 point. I give it a name. This file is fairly old. If you had old adaptive component families and you loaded them in, they actually gave you a different icon so you could know it was an adaptive component family. So all these old families I had inside here gave me this little adaptive component icon. They got rid of that at one point in time in Revit. I don't remember what release, and I'm really upset that they did, because I loved knowing that, hey, these components were there. So all of these are adaptive component families. All of these are adaptive component families. These ones are just really, really old created families in an old version of Revit. So it gave me that icon. Unfortunately, that has went away. But if you're wondering why I can see that here, oh, that would be why. So another example for me, like I've got this step footing adaptive component family. So I know this is one in structure. Every structural engineer has this little, step foundation family. But again, one of those things that you start getting into when you go to place it is you're like, oh, it'd be really cool if it automatically adjusted when I went through. Oops, I misclicked. Let me try that again. So it'd be like, oh, it'd be really great if when I placed this, or if the file started to update, it would automatically update that adaptive component family. Did I? Oh, I did it backwards. Sorry, I'm doing the wrong points here. Trying to talk and do the same thing. I believe it's a 1, a 2, a 3. No, it's going to go in backwards again. 4. Okay. So this is one of those things where sometimes you need to go look at the family. And so this is where I was trying to come in and play with this, is your users might not know how they need to place this family. So if I can come in here and edit this family, just to kind of show you what's going on with this family, is I can see that there is a point here, right? So you'll see that when you place adaptive points, you will start getting numbers. That one's got a number 1, number 2, number 3, number 4. I really thought I put that in the right order. Maybe I did it backwards. But you can start to see that you've got these different these adaptive points in here. So just the fact that I called it 4 point was cool, but if you don't get training or you don't have some sort of notation and documentation on this of how users can place this family, as you just saw with me struggling, your users might start to struggle as they get into it as well. So 1, 2, 3, 4 looks like it's going to be correct. Let me try it one more time. Now, the other thing about adaptive component families that can be really, really weird as well is the fact that I'm hosting it on that line versus hosting it on the end of this line can make a difference. So I'm just going to use the tab key, and you can see that I'm getting the end of this bottom line in this scenario. But before, when I was over there, I was getting the end of the edge line, and that's honestly probably what my problem was. So this is some of those nuances that you talk about with adaptive components in Revit, is even though I'm saying, hey, go to this endpoint, I might need to use the tab key to snap that to the other endpoint. Because depending on which endpoint you host it to, you can start running into issues on, hey, is this going to work or is this not going to work, right? So the first 2 times I placed it, I was grabbing the endpoint of the long surface, not the endpoint of the edge surface. So these are the nuances that can really start to drive you crazy when you go to place these families, or especially a new user or an unfamiliar user can start getting with that. The other downside to this is you will notice I have this under my structural connections. I would love to be able to make this a structural foundation or many other categories. When we go back into an adaptive component family from the template, we do not have all of the family types available to us. I am in Revit 23 and all the new Revit 23 categories they did add to the adaptive components. But prior to that, we only had like 7 categories. We had like casework, we had doors and windows, we had furniture, we had structural connections, but we did not have all of the components that you see here. So this is in 23, we did get new categories. But prior to that, you're going to see that you have very few categories. So that is another downside. If you want to make like my little roof cricket cannot be a roof category because we do not have that available to us. So understand that as well. That is another nuance inside the adaptive components, that if I were to go into VG and turn off structural foundations, cool. The strip footings, the isolated footings is going to show off, turn off. This one is not, right? I can still use join commands on these tools, right? So I can still join them to get this to clean, if I can click my mouse properly. I can still use the join to get my cleaning to turn up. But again, if I go into visibility graphics and turn off structural foundations, which I would love to make this, it is not going to turn off my adaptive component because that is a structural connection. The line weights are going to be different, etc. So just take that into consideration again as one of those things that start happening. Now, the other part that's really, really cool is this is my linked Revit model. All right, so I've got a linked Revit model, and all I did was place in this scenario a face-based object onto the linked Revit model. So these two elements will adjust with that face-based object. I do have, this is one that I use also common as well. I do have one for my, where is it? My clevis and rod. So I do have one for clevis and rod. And again, now I can come in here and be like, ooh, I want to place this on the midpoint of this surface. And then I'm going to come down here and say, okay, I wanted to place it, on the midpoint of this surface. This is one of those ones too, like I was saying, I'm actually going to place this one on the edge of the line, not the surface like I did a second ago, just so you can see the differences in those points. All right. So now when I place that component on there, what's great about this is if I select it, you will see that this point is hosted there. And before I showed you the point on the other end where I've got, normalized curve parameter, which I could change to segment length, etc. You'll see here that this is just giving me U and V values. So if you host it on a surface, you still get U and V values. I wish I could be like, yeah, put that at 0.5 and it's going to be centered in the object. Now the UV values breaks it down into however many surfaces this is, and it doesn't really help you in this scenario. So kind of a downside there. Over here, again, like I showed you before, I did host this right to this edge, and hosting on the edge again, now I get the normalized curve parameter it's put in the middle. Personally, for me, I have this little value built into here for this component here, where I can come back and say, hey, what is the start indent? This was my 0.1. I can go and say that's going to be a -3 inches, whatever I wanted to do. I built this into my family to be able to start coming in and saying, gee, let's go start adjusting where these clevises go through, etc. So just a little bit scenario, that's something I built in. But again, this wasn't anything nested to the linked file. I just hosted the face-based objects. One that I get quite often from structural engineers, and this is where I'm going to show you guys what's called a shape handle point, is I would love to be able to come in, and this is a linked file again, I would love to be able to host to a linked object, my architect's walls, and if they move the walls, I want my thickened slab to move with it. So I do have this one down here called my structural connection thickened slab 2-point. I'm going to grab this in. And what's great about this is I am going to host this to that linked wall. So I am looking at the end point of that linked wall. I'm going to try to rotate this around and look at the end point of this linked wall and place this object. All right, so this is my 2-point. You're going to see that I did place it in there, and now it's way the heck down here. So I've also built into this family what's called the shape handle point, which it should be, go to wireframe, it might be getting hidden. I'm having troubles in my new Windows 11 machine seeing shape handle points. I thought this one had a shape handle point. Edit the family just to verify. It does. It has a shape handle point. It's right there by the edge. So what a shape handle point is, and I'll try to find this back in the project, is when I grab this, oh, it's invisible. That's why I can't find it. So what a shape handle point is it's a point that you can move up and down just like a regular point. You get all the surfaces, but it's not an adaptive or what's called a placement point. So these ones you'll see have a number 1 and 2, but you also see that this shape handle point I'm using to control how far off it is from this 0.1 or 0.2, right? I'll load this back into the project. For some reason, I had that turned off. I don't know why, invisibility. All right. So now when I select this, I can see, I should be able to see my shape handle point. I'm really not seeing the shape handle point. I grab this and isolate those two things. Isolate elements. I do not see that shape. Oh, I wonder if invisibility graphics, annotations. Whoa. Adaptive points. They're all turned on. And is massing turned on? Mass, not massing here. Mass here. I literally just did this a little bit and nodes are on. So I don't know why I'm not seeing the shape on it. Screw it. I'm going to delete that. I noticed there was 2 of them in here. I don't know why I have 2 of them in here. I'm going to try this other one. Let me restore. Try this one more time. Grab the endpoint of this wall. Just going to grab the endpoint there for now. Come over here and grab the endpoint here. Okay. Let me hide my slab and let's get a hidden line again. Hide my slab. Try this one more time. I literally just did this. Midpoint of that wall. Rotate around. The thing you also find with the adaptive component families when you get into them is the orbiting becomes kind of odd. So here I can see the shape handle point over here. So over here I can see the shape handle point on this one. So we've got it. I'm gonna go switch around to the other side now. So what's cool about these shape handle points is just like an adaptive point, I can select it, even though it wasn't there for me to place, but I can select it and pick a host on this. So I can pick, in this case, I'm gonna pick anywhere underneath this slab. I'm gonna pick the bottom side of the slab. So what's cool about that is if I come in here now, since the underneath surface of this floor is my host, and I change the floor thickness to be a 6-inch thick floor, notice how that adaptive, or excuse me, that shape handle point is going to be moving up and down with that surface. So I can use that shape handle point to be picking up the thickness of my own model. I could have done it with an adaptive point, but in this case, I don't know what's going to happen. Then the other part that's cool is if the architect moves their wall, my shape handle point is going to, or my wall or my stuff is going, my adaptive points are hosted to their object. They're going to move right along to the right. So it's kind of cool the fact that I can host to a linked object, and if that linked object moves, this one will go along for the ride with it. So I'm going to go ahead and open up the link model. Yes, and I don't have to unload it. All single user files. So here's my linked model. Ignore and continue. I hosted it to this wall. I am just going to move this wall over. I'm going to save and close this file. I'm going to come in here and go into my manage links, reload that. Let's say okay. And ooh, it did not move with it. It has done that every single time. I must not. No, I didn't. Oh, I bet you I picked the end of the slab. I probably see again. This is where it becomes really, really careful. You've got to be careful when you're doing. If I grab this one and see, no, it became unhosted. Ooh. Okay, I'm gonna have to verify this. There's something didn't break in 23 because it's unhosted now. I don't have the host on it. I was thinking that maybe I just put it on the. So, at any rate, that should have worked. I don't know why it didn't. I will have to come back to that. So that's getting into adaptive components. That's what they are. So now, how do we go through and create those? So one of the easiest adaptive components that I use quite often is I always tell people just go create a surface. And prior to Revit 22, I used to use this all the time for canted walls. So I'm going to place 4 points. I already put 1 point down as an example. I'm going to come up here and place 2, 3. I'm going to place my 4th point. I'm going to select those 4 points and I'm going to say make adaptive, right? So I've now got my 4 adaptive points here. I'm now going to go draw a reference line. I'm going to make sure my 3D snapping is turned on, and I'm going to actually draw a line from the point 1 to 2 to 3 to 4, and then back to point 1. I'm going to make a little closed loop of lines here, right? I did use the reference line tool as opposed to the model line. There is a difference. If you use reference lines and you then say go create form, the reference lines will remain. If you use model lines and create form, the model lines become the surface or the shape you're starting to do. So I'm going to go in here and say create form. Now, when I go to do this create form, and it does this often, you can see these 2 little icons down here. If you're zoomed in too far, this is a really, really terrible UI experience in the Revit world. I'll do it again, but I'll zoom out. It also does terrible if you've got text scaling at like 200%, if this does not scale. So if you weren't at such a large or zoomed in too tight, or if you also aren't like me where I've got, you know, a ginormous resolution with text scaling at 200%, it's kind of weird. The first one is always going to say a solid, and the second one is always going to be a surface. All I wanted to do in this case was create a surface, right? So I've literally created a 4-point family, and this is just a surface. I'm going to go ahead and load this into my project, say okay. And what I love about this is now this is just a surface. So let's say you needed to do a canted wall or something, or any sort of weird shaped wall. I'm going to go 1 there. I'm going to go 2 there. I'm going to come up here and move it to 3 and then go to 4. This is a generic model that's now been hosted here, right? What not everybody knows is that when you go to create a wall and you have the wall by face is not only to a mass. If you actually look at the tooltip, it says mass or generic model. I can now do a wall by face based off of that. And of course, I picked the one with the 2 linked models. Should have done. That's great. That's okay. We're going to grab this point here, and we're going to say pick new host over here to this wall. And I'm going to grab this point here and say pick new host over to this wall. And then I'm going to grab this wall and say update to face, and boom, now that wall has moved. And again, if I start to move this around, the mass updates, I can grab the wall and say update to face, all right? So I have the capability to do very simplistic generic model adaptive points to start doing my sloped walls, etc. I use this a lot for slope soffits. I have quite a few architects who do slope soffits between 2 ceilings. I'll model one ceiling, I'll model another ceiling, I'll do my generic model 4-point, I'll click on the 4 edges of the ceiling, put that on there, do wall by face, and now if the ceiling sketch updates, so will my little slope soffit as I start going into it. So again, just kind of some of those uses when you get in there, when you start saying, hey, here's what we could really do with it. Here's how we can use these on a day-to-day basis. Okay, so going back into, that's not the right family, going back into my just generic model adaptive family, you can see that now I came in here and I've created these little 4 points, and we start placing things off those points. If you create something like a surface and you want to remove it, you don't ever hit delete inside of here, because if you hit delete and you had done this with model lines, you would lose all of those model lines. You might want to be keeping those model lines. If you do have a surface that you want to get rid of or go back to the basics, there is a button up here called dissolve. The dissolve basically says, hey, remove the solid or surface, but keep all the components that you use to generate this. So it's kind of another little tip to know that, hey, when you're going through here and setting this up, you can dissolve solids as you went through and start doing it. Now, another thing in my repertoire when I start getting into this is I have my own 4-point panel, right? And I use this 4-point panel for numerous things. One of the biggest things architecturally people start getting upset with is the Revit rails. If we're trying to do Revit rails in like a glass panel scenario, right? So if I come in here and start looking at this, if we try to do Revit rails with a glass panel, if we do it as a sweep, you can end up with crazy things like this. If we do it as a panelized system, when you start getting the panels in there, the panels might overlap at the end and you start getting weird scenarios. So for me, a lot of times when I get into this and I start working, I will just model in balusters. And then the cool part about just modeling, and actually these are termination, or these are not balusters, these are supports. But the cool part when you do that is you can then start placing adaptive component families and hosting them to those supports that you have inside of there. So you'll see that this one, I can start doing irregular shaped sizes. I'm going to kind of spin around here to get a better view. So I've got a really long panel, a short panel, a medium panel, whatever. We would not be able to do this in the Revit railings command. It's just not going to happen. But what I can do, and I'm going to look at my points here, it's 1, 2, 3, 4. I'm going to go create another one of these. And what I can do is just start, again, hosting it to something in the model. So if I go 1 there, I'm going to come in, zoom in, here's 2. I'm going to come up over here and get to the midpoint here is 3. And then I'm going to come down here and get to the midpoint down here as 4. Right? So I've now placed that, and I can start to do this. Yeah, it's a little bit tedious to place this, and if I had a giant hand reel, I probably want to be doing this. But by manually placing this, what's cool is since that's a support, if I unpin that support first, If I tab select to get the support and unpin it, and that support adjusts or moves, my adaptive component is going to go along for the ride. So as I start deciding and start manipulating my project, I can come in here and really start getting these things to be set up to what's going on to where I need it to be. Okay, so another little thing. So one of the ones that I have as a standard tool is my 4-point panel. Right now, over the years that I've been using adaptive components, when I came back here to this little standard family you saw, when I was looking at this, and that's not the standard family, family one, that's it. I hosted reference lines to these points, and then I just did a surface off of this. That's going to be fine if you're doing surfaces. But a lot of times what happens with Revit is these adaptive points can start to rotate and twist and do weird things, as you saw when I was trying to put that step foundation in based off of the surface they're hosted to. So these might not always be in an XYZ value. So what I end up doing quite often is hosting then a point on this reference line. So when I go place this reference point here, I'm going to make sure I'm set to draw on face, not set to draw on work plane. And then when I pick on a line, just like you saw in the project environment, this reference point now has the same values for normalized curve parameters, etc. Right? So I can start telling Revit, do I want this to be a normalized curve parameter? Do I want this to be a segment length? What do I want this to do? But the advantage of doing something like this is this point isn't going to rotate independently of this point over here. It's going to maintain a more static relationship. So when I start to do things like this, I honestly start hosting a point on this point, and then I might host another reference point up here, right? And then I might draw a reference line between those two things to start doing what I want. So if we come back and look at my rectangular panel that I use as a standard, you're going to see that it's highly parameterized inside of here. If I start pulling this down, you can start to see that I've got indents for my points. I've got offsets. I can start doing miters, etc. But if you look on the screen here, you will not see any like parameters like you normally would in the normal environment. So I wanted this panel indent to be, you know, like I'll just say 4 inches. I can go move that, change that value, and you're going to see that, oh, my panel actually offset to the outside 4 inches. I can come in here and make this a negative 4 inches, say, okay, cool, and now that panel's offsetting to the inside. What's happening there is I've posted a point on that reference line, and that point right there has an offset value. So if I come in here and grab this point, you're going to see this point then has an offset value. So what I'll start doing is hosting a point on a reference line, changing that to a segment length, then possibly hosting a point on that point using these offset values. And this is the most stable way I have found to do Revit adaptive components, right? So if I go back to, which one was this? This is, no, this one, the gray one. If I come here to this family one, where I was saying, so I can parameterize this little value from segment length. Sure, I wanted that segment length to be parameterized. I'm just going to call this one my indent. Let's say indent, right? And now I have just parameterized where I can move that. You'll also notice that if I change this from segment length there to here, I'm going to change this to be segment length, that the segment length here is like 19 feet. Like, what's going on? It's not 19 feet away, because it does allow you to change it from the beginning value or the end value. And now when I do it, you can see, oh yeah, that makes much more sense. That's closer to looking 3 feet. But I'm going to parameterize this with the same indent value, right? So now if I come in here and say, ooh, I wanted that indent to be 3 feet, and I change the value, you can see those lines are adjusting 3 feet. So what I'll do often again is then start setting a reference point. But before I place this reference point, I want to set a work plane. And by setting this work plane, you can see that those points you put in have 3 work planes, an X work plane, a Y work plane, and a Z work plane. So I can start tab selecting to be like, ooh, I wanted this horizontal plane to be my work plane, right? I'll say, okay, it's going to tell me, hey, you have 2 points on top of each other. I'm going to go set the work plane over here to be that, click this here and say, okay, give me a point on top of it. Then again, both of these points, I can parameterize their offset value. So I can say, gee, I wanted to offset those up 2 feet. Now I'm going to parameterize that. And instead of calling this indent, I'm going to call it offset. And I've now got an offset value, right? So I'm using this point on this line to move in and out, then I'm going to use this point and this point up here to move up. So you can start really getting overly complicated as you do this, but this is how I have found when we get into this, how you get through and set all of those up and start really making your panel as stable as it can be for adaptive components. A lot of times people would just be like, oh, I'm going to put a profile on here and host that profile and move that profile off. Again, every time I've tried to do that, I start getting weird scenarios. The best example I had is I had a client, they just had a 2-point adaptive and they hosted a rectangle. They drew a rectangle profile on this end. And then they said, sweep it along this path. And then as they were in the project environment, their little rectangles kept rotating and like twisting. So they were trying to make like a 4x4 wood sculpture with all these 4x4s different lengths, and they all kept twisting on them. By hosting a point on here and then putting a profile on that point surface, it stopped the twist. So yeah, this becomes a good thing. And Matt just asked, why did the offset parameter automatically assume the Z direction? So when I hosted this point here to this line was drawn a given direction. I'm going to host another point over here. So you can see I drew all these going around clockwise. So if I host a reference point on this one, and then I set this work plane, oops, I missed, try that again. Must have missed clicking, reference point, work plane, let me set this on here. And then if I go do another reference point and set this one, cancel, work plane to be this one and host it, yes, I know. And again, if here I come in and say, okay, let me go change the offset here to be 2 feet, it went down. So this is one of the ones that is very, very frustrating in the adaptive component, because I drew this one from 1 to 2. I went around all in a clockwise motion, but now this reference point all of a sudden decided that its Z value is going to be down, and this one's reference point decided that they're going to go up. And you can tell by selecting these what it's doing in there. I have not found 100% reason on why that's going to do that. If I took this line here and drew it the other direction, it would inverse that. So if I took one and drew it the other direction, it would inverse it. I honestly have not figured out why it does that. The nice part about adaptive components, unlike Revit families, is you can use negative values in there, right? So if I wanted this point to offset the same as this one here, but I understand this one is giving it there, what I will do in my formulas, and this I do quite often, is I will call this one my offset neg. And I literally will just put this as a formula of a negative of the other one. So when I start running into situations where I need this to be the negative or the inverse of that, then I will come in here and say, oh, gee, there's a negative value of this parameter, and just give it a negative version of that, right? Formula is just negative that. So in this case, this one that I need to go the opposite direction, I would use the opposite offset negative, right? The other thing that theoretically you could do, and I'm going to undo that real quick. The other thing that you could do, rather than saying offset negative, is you can actually grab this point, and you could say this point is going to be, it's not flipped, I forget which one it is mirrored. And if you mirror that point, then the Z value that starts to go up, right? So this is going to have the same 2-foot value. I have found that by starting to mirror and flip points, I've started running into issues where when I load it into a project, it will do bad things or just start blowing up for me. So I have learned that I don't ever do this mirroring. You think that would be cool, and hey, I should be able to just come in and say, hey, mirror that. It's going to do what it should do, and I should be fine. I haven't done that. You technically also could just come in and rotate that point 180 degrees. And you would be able to get that to do the same thing. Again, I have been using these for, over a decade now. And I found that when I start doing things like that, it works great in the family environment, but when you load it into the project environment, things just go weird. So for me, I don't ever mirror these. I don't ever rotate these. I don't ever flip these things. I leave them all at 0. I leave them where they are, and then I just build in negative offset values for what I need to do. I don't know why. I don't know the reason behind it. I've just found that that's the most stable way I've been able to do it. There was another question that came up, said, well, the models get slow if you have a lot of adaptive components. The only time I've really noticed the model slow down with a lot of adaptive components is if I nest adaptive components in adaptive components. If I come back here to my little sample file and look at the sample file over here, there's one up here that I had where I nested a nest and a nest and a nest, so that goes 3 deep. So I had a bolt family, and I nested that bolt family into an arrayed bolt family here. It's called a repeated bolt family. Then I nested that repeated bolt family into this plate family and repeated it up this way. Yeah, putting too many of these in, I've noticed the project goes slow. So when you start looking at something like this, it's really cool to see all those bolt heads. It's technically not even a bolt, it's just the bolt head. It looks great, but since it's 2 nests into here, these are the things I've started to see slow it down. The adaptive component families themselves just put in here, no, I don't notice any sort of slowing down on something like that. All right, but in my mind, this is one of the greatest things ever, because you can see that I've put this plate in here, and if I tab select to get all of these, right, they're all 6 feet off the ground. Well, if I was like, no, I want that value to be 8, all of those move. This should theoretically be a new custom structural component. It's not, because I'm just literally having these adaptive components. Oops, I accidentally selected something. I'm having all these adaptive components just go along for the ride. I'm just trying to get to the 8-foot value. Go along for the ride, and so they just start to update. All right, so it's kind of one of those, why I do it that way, it's why I set them up, and there's certain rhymes or reasons for things like this when you start to go through and set it up. So hopefully it answers those 2 questions. Oops, I keep bumping my mouse into the cable, that's why it's freaking out on me. So when I start coming back into here, looking back at these adaptive components, so yes, those are some of the nuances. Now, I did say I won't rotate these little values in general, but there are times where it's like, oh man, I wanted to literally have the capability to rotate this. So like my clevis and rod families, you'll see that if I come back here and grab this, there's going to be a rotation value that you can put on the start rotation or end rotation. Because maybe I wanted to come in and have the clevis go point one direction in one area and another direction in the other. So I could change those values. Looks like I have them broken and they're both looking at the same value. Oops, that's a broken family. But what I'll do is I'll start adding rotations to those. And how that happens is simply by rotating that point. So if I needed these 2 points to like be able to rotate out, I can select this one, I can select this one. And again, I can parameterize the rotation angle. So I can just, call this my angle, whatever. Okay, and now I can start coming into my properties. And if I go change that angle to be 15 degrees, say, okay, cool, make it a negative 15 degrees. It's going inside, it's going outside, etc. So you have the capability to start going through hosting points on reference lines, hosting points on other reference points, etc. So when we look at my overly complicated mitered 14 edge panel and we really start looking at this, it looks a little bit crazy, but it's even crazier. If I just come in here and start selecting this, you'll see that there are 66 points in this family, right? You're like, it's a 4-point rectangular panel, Brian. You went a little bit crazy on that, which I did to a point. But so when I started doing this, in order for the panel to be able to have a positive or a negative offset, what I did was hosted a point on the first reference line that goes inside of here. So there's a point hosted on this reference line. Then that point that's hosted on that reference line can have an indent in there. But if I wanted it to be outside of it, cool, I needed to make that point host a point that would let me go beyond where the panel is. So what I mean by that, if I come back over here in this little rectangle family, is cool. This point now I've got to be able to rotate, do whatever, but I want it to be able to have a positive or a negative value on here. So I will go set a reference point on that point, picking that vertical surface and hosting it. Yes, I know. And now I can give myself an offset of this one like 3 feet. And okay, that went inside, or change it to be negative 3 feet. And I'm going to go make it a negative 6 feet. And you can see now I'm past that hosted point. So even though my point might be hosted on something here, by hosting this point onto this point, now I can move it outside of the host. So when we come back here and look at my little rectangular panel family, that's why I have the capability to make it a positive or a negative value, is I'm hosting a point on a point. So if I wanted that indent to be, 6 inches, that is going to go outside of the the hosted point when we start looking at it. So it's a little bit crazy and start doing it, but that's why you'll start to see 66 points inside of here when I get into it, is because I'm hosting a point on a point on a point on a point sometimes. Now, that can be extremely confusing. So the other thing that I always tell people in normal families is name everything. So if I was to come in here, you will see you can name your points. So I can come in here and say, this is my 0.1 indent value, right? That's giving me that. And the reason why I would name this is now when I grab this point for future use, it's going to tell me its work plane is that 0.1 indent. So its host or its work plane, it's hosted to that one. So then I could call this one, you know, my 0.1 offset or whatever I wanted to call it. And now when I look at this point's going to tell me, oh, cool, that one is hosted to the 0.1 offset. So for me, as I go through and create all of these for future reference, or for when I give this to other clients, every single one of these points should be named. And therefore I can see, oh, well, that one's called this, it's hosted to this. So I can really start to see what's going on with all of this hosts, what's going on, how are those all pertaining to it. So in this example here, I've got this value in here, and I've done a little bit of math or whatever, but I can come in here and say, ooh, I wanted a 45-degree angle between points 1 and 2, hit apply, and now you'll see a whole lot of points became offset. So these points look like they were all on top of each other, but now you'll start to see more points lining up. Okay. The other thing that becomes critical when trying to work with something like this, and that's really, really cool, is if I come back, one of the options when you're hosting a point, and I am just going to go do a reference line real quick from here to here. And I'm going to do another one from point 2 to 4. And then I'm going to host a reference point on this line. So one of the other things that's great is I can take this point, and at this point selected, I talked about all the normalized curve parameters, etc. But the other thing you can do is host this point by an intersection, right? So I can say, ooh, whenever that point, it's hosted to this line, but I want it to be hosted by that intersection there. So now this point is hosted to this line, but it's going to go wherever that intersection is. So if I take this point here and start moving it around, you'll see that point is staying on the intersection. Even if I move it up or down, try that again. Change number, move. I can now move that down, and even though I moved it down in plan, it's still hosted by that intersection. Well, intersection perpendicular from this line to that. So it's like perpendicular. So you can start to get things like this set up, and this point is then going to have that inside of there. And part of the reason why I do that, I believe this rectangular panel has it, I like to know if these panels are being deformed. So if I go into wireframe and look at this, I've actually just done 2 diagonal lines. I hosted a point on one of those, and then I said host that point by intersection. So if I move this down, Revit's going to measure the distance between the point here, and then I did another point up here and said by intersection, and then I ran the dimension between the two. So I did a reporting dimension between these. So now I can see, am I placing this in the project, is that panel flat, or does that panel have some sort of deformation to it? So another tool that hosting those by intersections, and then just simply running a dimension between those 2 points, making that a reporting parameter, I can now report back to what's going on. Hey, this panel is deformed. So I've used this in quite a lot of projects for mostly Q&A, that I know these panels are going to be flat, but hey, when those panels are flat, or are they flat when we place them? Did we click the right corners? So we can have that capability to see if there's anything other than 0 for the deformation. We probably clicked a different scenario. Okay, so just kind of making sense to everybody. I'm only getting a couple of questions inside of here. It does get curious. And also, if you guys want any of these families, like my 4-point rectangle or my roof cricket, whatever, just email me. I'll put my email show up in the PowerPoint at the end. Just email me and I will gladly send you either of these families. It doesn't matter to me. I don't know if you'll be able to reverse engineer this family, but you'll be able to have it to try to possibly start looking at what you've got going on there. Okay, so with these families, I still do kind of the same similarities, right? If we even come back in here, there are going to be some, again, like I said a little bit before, there are going to be negative values. So I've got a panel offset value, and then I've got a panel offset negative. Again, one of those ones where I think Matt asked, why did the Z direction go up in that scenario? Not always going to happen. So you're going to see for a lot of these, you're going to see, oh, I've got the panel thickness and I've got the panel thickness negative, right? So I've got a lot of these scenarios when we start getting in there. For my one to do the miters, I went through and actually made formulas for the miters. So I did go a little bit math here. You could rotate the parameter or the reference point around, like I said. I haven't found that to be as stable. So for me, I just did it with values for the offset. So I actually offset it based on the miter. So I've got a point that says, hey, offset this over whatever distance based on the panel thickness and the tangency of those, etc. So different things going through on scenarios like that. The other thing that you will see that I always like to do for my adaptive component families is everybody always wants to know, how big is that panel? So I do have reporting parameters. I talked about the reporting parameter for the deformation, but I'll do the same thing for like these values here. So like you'll see I've got these width points here. So if you've never done this before, you can put a dimension in. And that dimension then can be what's called a reporting parameter. So I am just going to do a terrible example here, but I'm going to go ahead and set my work plane. Set, now I got to go pick. Set work plane to be the end of this dot, right? So I'm horizontal to this dot. And then I'm now just going to go dimension from this node to this node and place it. Cool. So this one's being rotated, it looks like. Oh, that's right, because I worked this panel. But what you'll be able to see is, so now when you grab this, I can go label this dimension. I can add a parameter. And when you're adding a parameter, if it's instance-based, you can check this little box here saying it's going to be a reporting parameter. So that's how I did this for my widths at 0.1, widths at 0.2, etc. I did these going to where those panels are. So even this one that has the, I'm going to go back to hidden line mode here. Even though this is not coming from the adaptive component, I did a dimension from that point, which controls it, or not that point, which controls the width of the panel, to that point down there. So now I can have this. So when I load this into my project environment, oops, wrong project, this one, I believe. So when I load that into my project environment and use it, when then somebody comes back and says, hey, how big is this panel? I do have those values inside of there. So, hey, it's going to be 3'2.5" by 3'5" and 61/64 of an inch. So that is how big this is going to be based off of it. So that's another thing that I built into these. And again, you'll see my deformation value. That's just, hey, is this panel being flat? And again, part of the reason why I do that, if I come in here and grab that point, just to be terrible, I'm going to say pick new host. I'm going to say we accidentally slipped and picked right there, right? So now with that panel selected, if I go back and select that panel, you'll see that, ooh, my deformation is 0. Why is my deformation 0? Dang, oh, this might not actually have that value built into it. This is not my rectangular family. This was an old version of this. Could be an old version. But I should have seen deformation not being 0. I'm gonna have to go and edit my family and see what's going on there. So then I could know, oh, you didn't choose the right value. You need to, obviously make your glass flat. Okay, so those are just things I do. I like reporting parameters for sizes because inevitably somebody is going to ask it. Also for me in that family, it happened to be a shared parameter, so we can also schedule it. So if I do come in here and edit one of these reporting parameters here, you will see that this is a shared parameter. Only reason it's shared is so that way we can put it into a schedule when somebody says, I need to know the sizes of this panel for X. Okay. So I think that was pretty much everything I had. Different template types. I talked about the thick and slab edge. Oh, a couple other just helpful hints when you get inside of here. Okay, I'm gonna go here and show this one real quick. If you do back here, if you do make a surface from like the, let me just do another one here real quick. I'm gonna do 2 reference points. Boom, boom, boom. Looks great. I'm going to draw a reference line between those two. I don't need chain, but I do need 3D snapping from here to here. I'm going to go put a reference point on this one, and then I'm going to go set that to be my work plane. I drew this at some sort of crazy weird angle. And then I'm going to go draw now just a rectangle on that work plane with reference lines, right? So if I grab this line and I go say create form, am I parallel to each other? I am. I picked the wrong work plane. Delete those. Try that again. I didn't realize I was at a crazy angle. There we go. Reference rectangle. Rectangle. One of the things that I found when I was trying to do something like this that became really, really weird is when I created a form, I wanted to change like the size of the ends or not the size of the ends. There's this button up here called lock profiles, right? If that is highlighted, then it's going to be locked. And what it'll mean is you're getting consistent thickness going down. This is particular when you do sweeps. I had done this and I had parameterized the little profile here. And when I changed the parameterization of this, since it was just a sweep in this case, it only changed it where the lines were, not at either end. And I was like, oh my God. So I was making all these sweeps crazy with like 2 points on it. Those 2 points then were hosted at the end. And then I realized that it's simply the fact that if you use reference lines, it's locked by default. If you don't, it's not. So this is just 2 buttons I want you to be aware of if you're using, make this form along a path. I had to way overcomplicate my very first family that I did back in 2009. And then I don't remember who it was. I think it was Scott with Autodesk. Oh, just hit the lock profiles button. I'm like, really? That's all it is? Dang it. And so that became a huge, huge tip for me. So locking the profiles, the directionality lines, and I touched base on this a little. I touched base on this a little bit when we got into it. Directionality of the lines. If you draw a reference line going right to left and left to right in one version, the directionality of that can make a difference on where those nodes are going to be going for like your offsets, etc. So just be cognizant of that. The other thing about, if you talk about this, is shared. The out-of-the-box template, when you start, has this as a shared family. So when you start with the out-of-the-box template, the adaptive component family is automatically shared. So if you load this into another adaptive component family and then load that into your project, it will be coming along for a ride as an option. I say this because I have some adaptive components. When I first started, I was just using model lines hosted on a point so I could use it as like a profile for sweeping. And when I did that, I kept getting it as an option. I'm like, oh, by default, the out-of-the-box template has it as shared. So just be careful of that when you start getting into it. All right. And with that said, I think that is pretty much it. Yep. So there is my email address and my Twitter feed if you guys want to follow up with any questions or any thoughts. And Caitlin did ask, are my Revit Radio sessions recorded? Yeah, if you go to the Revit Geek YouTube channel, I have 5 whopping recordings on there. It is all my Revit Radio recordings. I will try to put those in here real quick in the Q&A pod before we end the recording. So hopefully that'll come up in the Q&A pod. And it looks like we, yeah, I should have started with this. Somebody else asked, how did I get the fun color-coded tabs in my Revit? There are 2 add-in utilities to do it. If you're actually using PyRevit, which now is out for 23, if you guys did not know this, in the PyRevit drop down under settings, under UI, you can go through and set that up. I personally am not using that one. I am using the add-in that is a paid add-in from Parallax. It gives me view sorting and a few other options that I can do that PyRevit doesn't do, but you can use either of those, and that's how I get those color-coded tabs. So hopefully that gets it going for you guys, and I appreciate everybody for killing an hour of their time to learn about adaptive components, and hopefully we'll start to see some of those in some of your guys' actual projects. Thanks, everyone.
Hey there, thanks for tuning in. If you like this video, make sure to subscribe and check out some of the other content on our channel.